Hi everyone, I am Vijay. My teammates are Manjunath, Manikanta and Nikhil. So today I am going to explain about Canny Edge Detection project. So first we are loading an image and applying Canny Edge Detection, and we are importing a CV2. Here it reads the at.jpg, and I have written a 1 because it represents one specifies the color, and 0 could be mean grayscale, and -1 includes the alpha transparency. So edge image stores the loaded images. This stores the loaded images, and cv2.canny, this cv2.canny image comma 0 comma 0, it applies canny detections algorithm to image using hundreds as both the lower and upper threshold for edge detection. This is the threshold. And cv2.im show, it displays the original images in a window titled as the output. Next, display the edge detected image in the same window, replacing the previous one. Next, it keeps the window opens for 5000 milliseconds, that is 5 seconds, or until key is pressed. Next, and we are importing, for further we are creating a blank image for and coloring it. So we are importing a numpy as a np, and it creates a black image of size of 5112 into 5112 pixel with a 3 channels rgb and data type, and it prints the pixel values. It prints the pixel value of a blank images which are initially all zeros. That means black. Zero means black. So it colors the entire image red by setting all pixel value to 0 comma 0 comma 25, that is bgr format. Blue is equal to 0, green is equal to 0, and uh, red is equal to 255. Yeah, this line. And next, cv2 dot, these two lines displays the red image in a window titled as image, and waits for 50,000 milliseconds, that is 50 seconds, or until key is pressed. So this is the section 3. From here, this is section 3. We are reading an image and applying a filters. Load the load aat.jpg and displays in a window titled as a original, and it waits for indefinitely for a key press before closing. And next, bgr, like we are going to converting image from bgr color to grayscale. And it here yeah, it applies a Gaussian blur to grayscale image to reduce the noise. The kernel size is a 3 into 3. Kernel size is a 3 into 3. 3 into 3, and a standard deviation is 0. And standard deviation is 0. So from here, this is the Canny detection program. From here, it is the Canny detection program. It detects the edges. It detects the edges using the Canny algorithms. Canny algorithm. The threshold are set to 100 as a lower and 200 for a upper, and displays the results in the form of the Canny, and it displays the result in a window titled as Canny. So this is a Sobel Edge Detections. Sobel Edge Detection. We are importing cv2.sobel. It computes the gradients in the images. SRC image is equal to blur. The input blurred grayscale image, and ddepth is equal to cv2.cv-64f, the depth of output image. Next, dx is equal to 1 and dy is equal to 0. It detects the changes along the x-axis and a y-axis. This is x-axis and a y-axis. And cases, it is a kernel size of 5 into 5 for a convolution. And similar to the Sobel y, it detects the changes along the y-axis. It's same as like x, but it detects along the y-axis. So let's come to the next, Sobel xy. Sobel xy is similar. It displays the Sobel gradient images for x and y and both direction, and a separate window. So in this Canny detection, again another demonstration of a Canny edge detection with a similar pattern, and display the detected edges in a new window. It detected the edges in a new window. So this is the program of this is the explanation of all the program. This is the explanation of code, and let me explain the output. So I am going to run this program. I'm going to run this program. It's taking time. And see, this is the output of the program. And it is the original. This is the original image. Sorry, this is the original image. This is the original image. So if I press next button or if I wait for 5 seconds, it's going to be automatically will change for the another next output. This is a sobelx or sobely or sobelxy, and it keeps going. So this is the canny. This is the canny. This is the canny edge detections. This is the canny output. The edges are displayed with a white lines on a black background. So let me press next button, or if I wait for 5 seconds, it's going to be display. Let's press it. And this is sobelx. This is sobelx. It highlights the horizontal edges. I mean rate of intensity agents along the x-axis. So next is sobel y. Sobel y. It highlights the vertical edges along the y-axis. So next is sobelxy. Sobelxy. It combines the both horizontal and vertical edge detection. This is the final output. That is the can edge detection. That means detection outlines in the edges are displayed with a white lines on a black background. This is the code explanation and the output. So thank you.